Hello dear students, I am Surendra Sir, Master Teacher of Mathematics in Vedantu. In this session, I am discussing HWT Test-10 that is based on limits and methods of finding the limits. So before we start doing the questions of this assignment, this test, I would like to give you few ideas which are must know before you solve the questions. So first one is standard results. So dear students, these are few results 1, 2, 3, 4, 5, 6, 7, 8 results that I will recommend you everybody must know. So first one is x power n minus a power n upon x minus a when x is tending to a. So in this case your limit becomes n into a power n minus 1. Those who know LH rule, L'Hopital LH rule, so you can differentiate numerator and denominator and then put x is equal to a. That is also fine, but whatever way you remember it, you must remember it. Okay, then sin x upon x, it is equal to 1 when x tending to 0. Here also using LH rule you can find it. Similarly, tan x upon x is also 1. 1 minus cos x upon x square. Some of you may not remember this, but I will recommend that this is also very important. It will simplify your calculation. It will save your time. This is actually equal to 1 by 2. Okay. Then coming to this thing, if ln, so natural base if it is, then it will be 1 when x tending to 0. But if it is not natural base, then it will be 1 upon ln a. Okay, if it is e power x minus 1 upon x, it will be 1. If it is a power x minus 1 upon x, then it will be ln a. Okay, so you can see between these two, ln a is coming here. In this case, ln a is coming in the denominator. So all the result you must remember. Now second thing is the expansion. Everybody must know what expansion is. So I have listed only 5, I think 1, 2, 3, 4, 5, 6. 6 expansion I have listed, and these are must. You must know. I think e power x is not very difficult to remember. It becomes like this. And so on. It will go till infinity. For sin x, it is very much similar to e power x. You just have to copy the odd terms of e power x. That means x upon 1 factorial. But the next odd term will come with minus sign. So minus x cube upon 3 factorial. Then x power 5 upon 5 factorial. And then x power 7 upon 7 factorial with minus sign. So this is your sin x will be written. Cos x will be having all the even power of e power x starting with 1, but next one will be with minus sign. X square upon 2 factorial with minus sign plus x power 4 upon 4 factorial, and then and so on will go till infinity. Now tan x. Tan x is x and then x cube upon 3. And the next term is 2x power 5 upon 50. And so on. Dear students, this tan x, you may not need this term in most of the question, but I will recommend that you remember till these 3 terms because it is not easy to derive them in exam if it is needed. So it will be better that we remember till 3 terms. For log x, again it is having some pattern. You start with x, then minus x square upon 2 plus x cube upon 3 minus x power 4 upon 4 and so on till again go till infinity. Okay, this will be for mod x less than 1. In this case, 1 plus x power n, this will be just a binomial expansion. You just think of nc0, nc1, okay, but write 1 in place of nc0. If n was, let's say, natural number, then writing it nc0 or 1 is same thing. But if it is not natural number, then nc0 is not defined. We will rather write as 1. The next term would be n into x. This n is actually coming from nc1. And then n into n minus 1 upon 2 factorial into x square. This is actually coming in place of nc2. And so on and so on. So you can see 1 plus x power n is just binomial expansion. You just need to replace your nc0, nc1, nc2 expansion, nc2 values from their expressions. So this is how these 6 expansions are. Please do remember them. Okay, there are conditions, sometimes mod x less than 1. I think these 3 are for all x belongs to R. I think tan x is also having some condition. Here also I think mod x has to be less than 1. But that is not important for us because we need to know what will be the limit when x is tending to 0. So for question solving purpose, I will say these expressions are required and they will be useful when your function is asked when x is tending to 0, when limit is asked as x tending to 0. So these will be useful at that time. Now there are 2-3 forms other than the standard things like 1 power infinity and 0 power 0 and infinity power 0. What is 1 power infinity? Please understand, 1 power infinity means it will be like 1 plus fx raised to the power gx, where your x, whatever x you are given, this fx will be tending to 0 and this gx will be tending to infinity. So you can see 1 plus 0 becomes tending to 1 and this is tending to infinity. So it is actually 1 power infinity. Now for this kind of questions, if you are looking for limit, there is a special method to take log. Okay, we will be writing this as e power gx into ln of 1 plus fx. Now just one step and you can write this thing as e power gx into fx. Actually this is coming from that standard result of ln 1 plus x upon x is equal to 1. So if fx is tending to 0, so ln 1 plus fx will be tending to fx. So this is how we are writing it. Okay, now this is one very important result. We have to use it directly. So whatever x is tending to a or whatever, let's say x tending to a, where fx is tending to 0, gx is tending to infinity. So your limit will be now found using this e power gx into fx. Now this is infinity into 0 form. Now you can decide whether it is to be done using standard result, expansion, LH rule, whatever you feel better, just do it after this step. Now 0 power 0 means it will be some fx raised to the power gx, where fx will be tending to 0 and gx will be tending to 0. I am talking about first 0 power 0. In this case again take log with the same method I told you here, e power gx into ln fx. Now because fx is tending to 0, so this will tend to minus infinity, provided this is tending to 0 positive. Okay, so that will be tending to minus infinity, and gx is tending to 0. It can be 0 plus or 0 minus, doesn't matter. So this product will be 0 into minus infinity form, similar to here. So after that you may use LH rule. You may use LH rule, or after actually LH rule if you are looking for, then you have to do one thing. Yeah, you have to write ln of fx whole divided by 1 upon gx. Now this 1 upon gx function is also tending to infinity. This is also tending to minus infinity. So infinity upon infinity, this could have been minus infinity also if gx was tending to 0 plus or 0 minus. So this will be infinity upon infinity. So use LH rule or other methods also if you feel they are better. Now infinity power 0 is also same thing. If your fx is tending to infinity and gx is tending to 0, so we will be writing this as e power, I am writing it directly, ln of fx ln of fx whole divided by 1 upon gx. Okay, see fx is tending to infinity, so ln of fx will be tending to infinity. This will be tending to plus or minus infinity. So then you can apply LH rule or other methods will give you the answer. Okay, now let's start doing the questions. The very first question is this. When we are given L, the first function is this and cube root of this thing and so on, and another function is given in terms of ln. Now we have multiple ways of doing this question. So let me try a few methods. So first method is, let's say, expansion for L. So we will be writing this as 1 plus 3x raised to the power 1 upon 3 minus 1 plus 2x raised to the power 1 upon 2 upon x square. Limit x tending to 0. Okay. Now if you apply expansion, the first two term would be 1 plus 1 upon 3 into 3x here. Okay. Whereas here the first two term would be 1 plus 1 by 2 into 2x. So you can see these two terms are getting cancelled here, so it will be 0. So we have to consider the next term, which would be here 1 upon 3 into 1 upon 3 minus 1, so minus 2 upon 3 upon 2 factorial upon 2 factorial, and then it will be 3x whole square, that means it will be 9x square. Okay, there will be other terms also, but we can ignore them. Similarly, here also we can write 1 upon 2 minus 1 upon 2 upon 2 factorial, and that will be 2x whole square. Other terms can be ignored because your x square terms are not getting cancelled. You can check after this calculation. I think these two are getting cancelled, and this 9 will cancel. I think these 2, 3. So this will be, I think, minus 1, and this comes out to be plus half. This x square will cancel it, so we are getting minus half for this part L. Okay, that is the one method. You could have done it by LH rule also. You could have done by standard method also, in which you will be writing this limit x tending to 0, and this is 1 plus 3x raised to the power 1 upon 3 minus 1. Wait, I think this will not work here. This will not work here, sorry. Why it will not work here? Because there is x square in the denominator, and the x terms are getting cancelled in these two, so subtracting 1 and subtracting 1 here will not work. So dear students, you have two methods, one is expansion and one is LH. So these two ways you can do it. Now coming to M, that's the second part here. So for M, the value would be again x tending to 0. So you can apply LH rule also, but if you are applying LH rule, let me tell you one short trick here. X tending to 0, we will be writing this as ln of cos x upon x square into x upon 10x. Now this x upon 10x can be written as 1. Now here this is one important thing. Many students feel awkward that how we can write a value in between. Dear students, whatever limit of this function will be now, and if it is 1, okay, suppose this is 0, this can be infinity or this will be finite. You can see if this limit is 1, it will be directly multiplied with 0 or infinity or some finite value. So there is no impact whether I put it here or I put it later. So you can directly put it 1 here. Don't worry about that, and don't linger on your calculation, because this, if you do not putting 1, you will keep repeating this in many steps, and eventually you have to write it as 1 only. So please put it 1 immediately. And now you can apply LH rule. LH rule means differentiation. So 1 upon cos x into minus sin x, and this is 2x here. Now sin x upon x limit is 1, and cos x at 0 will be tending to 1. 2 is 2 only, so this becomes, I think, minus half. So this is also minus half. So minus half upon minus half they are asking. So answer of this would be B. Okay. So I hope you have understood one method for this. I can give you another method for this also. Let me just give you the next slide. For M, the second method could be limit x tending to 0. Okay, and write cos x as 1 minus 2 sine square x by 2. Now, if minus 2 sine square x by 2 is here, for that I have to multiply by minus 2 sine square x by 2. And in the denominator I can put x square, and for that you will be multiplying by x upon 10x. Okay, now this is your standard result of log 1 plus x. So this will be 1. Now in this you can see it will become minus half, because sine square x by 2. You can write this as x square upon 4. So this will be minus 1 by 2 here. And the last one is also 1. So this is also giving you minus half from here. So this can also be the method for this M part. Now coming to the second question. 10x raised to the power cos x. Now please look at this. I think this is infinity power 0 form. 10x will tending to infinity, cos x will be tending to 0. So we can write this as limit x tending to pi by 2 minus and e raised to the power cos x into ln of 10x. Now here I think LH rule is the method. E raised to the power ln of 10x upon secant x. Now this will be equal to limit x tending to pi by 2 minus differentiation of ln 10x will become 10x in the denominator and secant square x in the numerator, and the differentiation of secant x will be secant x into 10x. So one secant is getting cancelled here. if I write everything in terms of sine and cos, so secant x is actually 1 upon cos, tan is sine upon cos, so this cos square will come here, but one cos will be cancelled, so cos x upon sine square x. I think I just missed e here, I missed e here. Now if you put pi by 2 in place of cos, it will be 0, this will be 1, so it becomes e power 0, so answer of this will be equal to B. Answer will be B. Dear student, this is the only method I will say, unless you have some understanding of how infinity of log 10x behave, I will not talk about it, although some of you, if you know, can go that way also. Okay, let me tell you, limit x tending to 0, x into ln 10x. Okay, this limit many of you have found already, x into ln x, that tends to 0. You can say log x, ln x tending to 0 will be tending to infinity, but this infinity as compared to the 0, this is not that strong, you can say this becomes 0. So using this thing here, also we can find the limit, but I will not ask you to do the experiments in exam. If you are not very comfortable, go with your this LH method. This is not very difficult, I will say. Now this question, here x tending to 0, so cos x will be 1 and a sin bx will be 0, so this is just 1 power infinity. But there is one problem here. This cos x is tending to 1, it is not equal to 1. So what we should do, we should write this as 1 plus cos x minus 1 plus a sin bx and whole raised to the power 1 upon x. Now I will call this as my fx function, which is tending to 0, because this 1 is now absolute 1 and this 1 upon x tending to infinity. So to find the limit of this function, we will write this as limit x tending to 0 e raised to the power cos x minus 1 plus a sin bx, and I will write upon x in two parts, I will say. Now dear students, if you remember, 1 minus cos x upon x square was half. So for this part, if I write x square here and x here, so this will be minus half. This x multiplied, which is tending to 0, will make this as 0, whereas this limit will be a into b only. So this becomes e power ab, and we are given this as e power 5. So a into b is coming out to be 5. So they are asking a upon b, and options are in terms of b or absolute constant values. So I think a upon b, if I write, it will become 5 upon b, so 5 upon b square. So answer will be D for this question. Okay, at this step you may use LH rule, you may also use expansion, but I will say this is the best method. Expansion can be done, LH rule can be done, not difficult at all. If you have to find the limit of cos x minus 1 plus a sin bx upon x, and you are not very comfortable with these things, then my second best method will be LH rule here. If you differentiate it, minus sin x plus a into b cos bx upon 1. Now putting x is equal to 0 will make it 0, will make this as 1, so the limit will be ab. And same thing we got here also. So second method for this limit would be LH rule. Now this question, f 0 comma infinity to 0 comma infinity be strictly decreasing function such that fx upon f of 2x is equal to 1. Now they are asking x tending to infinity fx upon f of 4x. Now dear students, this question is actually a bit tricky, I will say, because whatever they have given, only that is to be used to find this limit. So for this limit fx upon f of 4x, I can write this as x tending to infinity fx upon f of 2x into f of 2x upon f of 4x. Now this limit, we know it is 1. Now dear students, I think you will understand, if as x tending to infinity, 2x is also tending to infinity. So this is also actually the same function here, Because when x is tending to infinity, you cannot say that x is tending to infinity, but 2x is tending to double infinity. So this may not be the limit. I hope you understand what I'm trying to tell you. If this is tending to 1, this also has to tend to 1. So answer of this would be 1 only. There is one more question similar to that. Let me tell you, dear student, I also got stuck to this in this question when I saw this question for first time. If it is a decreasing function, so fx will be bigger than f of 2x. F of 2x will be bigger than f of 4x. Okay, and codomain is positive. So if I divide by fx, that is a positive quantity at all places, sign will not change. This limit will tend to 1 only. This we are given as 1. Okay, now what about this? This will be less than 1 for sure, but by this we cannot conclude it will be 1. Dear students, sometimes they give you this limit as 1 and they ask you this limit. In that case, if this limit becomes 1 and this is already 1, this in between thing will have to be 1. That is called as sandwich rule. You might have done in your books, in your classes. So this will also be 1, but in this case sandwich rule will not work, because this is 1, this is 1. You can't comment this will be 1 or some lesser value. But from this method we can definitely say it will be 1 only. So now coming to the next question. Yeah, a into e power 2x plus b cos x plus c into ln 1 minus 2x upon x sin x is equal to 4. Now this question you can do in two ways. One is expansion and one is LH rule. So let's try to do this question by expansion. But before that, let me tell you, dear students, this question also I would like to write this as x square. I told you in one of the question here itself, in the session itself, if you write this as x square, you need to multiply by x upon sin x, which will be 1, and I can very comfortably write that as 1. So I will be immediately replacing this by x square. Even if you do not do it, it will be giving you same answer. So what is the expansion of e power 2x? I think 1 plus 2x upon 1 factorial plus 2x whole square, that is 4x square upon 2 factorial. I think only two terms are needed because in the denominator we are having x square plus b into cos x. So it will be 1 minus x square upon 2 factorial plus c into ln 1 minus 2x. So it will be minus 2x and minus 2x whole square upon 2. So this will be the expansion of this and upon x square. Now, if it is 4 and in the denominator we are having x square, that means degree in the numerator should also be x square and its leading term should be equal to 4. So all the term which are having degree less than 2, that means constant term, which is a plus b, so that should be 0. And then coefficient of x should also be 0 because it is x square here. So 2a minus 2c will also be 0. And then coefficient of x square, which is I think 2a here and minus b by 2 here and minus 2c here will be equal to 4 actually. 4, not this thing, 4. Okay. So these are three equations and we just need to solve these three equations and we will get the answer. I think after solving it, we are getting c is equal to 8 and a plus b is equal to 0. So I think a plus b plus c they are asking. So answer will become equal to 8, that is b. Okay. So moving to the next question. Dear students, I will suggest you please try this question with LH rule also. So the method 2 will be LH rule and try it. I am sure you will see same equations being formed. Actually, when you apply LH rule and the denominator is 0, your numerator should also be 0. Otherwise, you cannot apply LH rule. So if you put x is equal to 0, you are getting a plus b. Okay, this is already 0 at x is equal to 0. So that will be equal to 0. So this is the first equation we are getting here also. And then you will be differentiating numerator and denominator will be 2x. So after first differentiation, when you put x is equal to 0, okay, which will be 2a e power 2x minus b sin x, and in this case the differentiation will become minus c upon 1 minus 2x into minus 2 upon 2x. In this case also your denominator is 0, so numerator should also be 0. So this will give you 2a, this is already 0, and plus 2c, and that is equal to 0. So you can see this same equation we are getting here. Why it is not minus? Yeah, actually this was plus here, so this will be minus here. Okay, now one more time, if you apply LH rule, this will become 2. Now whatever you are getting it here, one more time, if you apply the LH rule, it will become 4a e power 2x. For this it will be minus b cos x. For this it will be, I think, minus, or let me write first plus only. I think this will become 4c upon 1 minus t 2x whole square. Let me check. It was minus, so it will remain minus only, because 1 minus because of 1 minus 2x in the denominator, and 1 minus because of the coefficient of x. So it will remain minus only. So this has to be equal to n upon 2, and that is equal to 4. So if you put x is equal to 0, we are getting same equation. You can check it here. 4a minus 4a by 2, so 2a minus b by 2, and minus 2c is equal to 4. So these three equations you have to solve, whether you go by expansion or you go by LH rule. I think I will go with expansion if you remember the results directly. Okay, now this bit trick in this part, please see. Here what will happen, we will write limit x tending to 0 e square minus, for this we will write this as e power 1 upon 2x into ln of 1 plus 4x. I told you one tricky way to take the log. So this we will write this as e power log of everything. So 1 upon 2x will come this side, so we can write that way. So limit x tending to 0 e square minus e raised to the power 1 upon 2x into, for ln 1 plus 4x it will be 4x here minus 4x whole square upon 2. I think that much will be sufficient, whole divided by x. Now you can see limit x tending to 0, e square is coming out to be common, that will be 1 here minus e power, and this I think minus 4x upon x. There will be some other terms also, but they will not be of any use because in the denominator we are having x. If it was x square, you have to take care of other terms also. So this is e square, and the limit of this will be, I think, 4. So answer of this question becomes equal to 4e. This part you can use LH rule, you can use standard result, you can use expansion. Whatever you do, answer will be same. Now this question, alpha and beta be the roots of this quadratic, then the value of this. Now dear students, please listen carefully, because alpha beta are the roots of this quadratic. So if you put x is equal to alpha here, this will become equal to 0. Now if it is 0, it is actually 1 minus cos 0, which will become 0. So 0 upon 0 form. Now if it is 0, dear students, please understand, ax square plus bx plus c whole divided by ax square plus bx plus c, if I write this way with whole square here. Now this will be that standard result I told you in the beginning. This will be 1 upon 2. 1 minus cos x upon x square. For that I have to multiply by this quadratic, which I can write it as x minus alpha into x minus beta using factor theorem. This upon x minus alpha whole square. Now this will become equal to half. This will cancel. Now putting x is equal to alpha will give you a square into alpha minus beta whole square. So the answer of this question should be half a square into alpha minus beta square. That is the best method of doing this question, let me tell you. Otherwise you can use LH rule also, it's your choice. Or some people convert 1 minus cos x in terms of sin x, that way also you can do it. But your answer has to be same whatever way you do it. So what are the methods? 1, then 2 converting in terms of sine, method 3 LH rule. Okay, so these are the methods. So I will go with this. Try with these two methods also. So that's all for this session. Thank you so much, dear students. Bye.